Hi, in this video we will learn how to find volume of a parallelepiped in R3. Well, let's see first what is a parallelepiped. It is basically three-dimensional version of parallelogram. So when you have three vectors u, v, and w, let's see, u, v, and w. Well, you using any two of those, you can form parallelogram. So for u and v, you have this parallelogram. For u and w, you have this parallelogram, and then you can use this one also. But if you do a three-dimensional version of that, what you'll find is that there is a box kind of thing, but the corner, one of the corners is fixed by u and w and v. This is parallelepiped, uh, determined by u, v, and w. Well, this is three-dimensional thing, and we want to know what is the volume of such objects. So the volume of the parallelepiped determined by u, v, and w is, this is a formula, you have to use it very carefully. So pick any two of these vectors. I'll pick u and v. So cross these two vectors. You will get another vector in R3. Then you can find dot product of that with the third vector. Here it's w. First cross product of two vectors. The resulting vector, you find the dot product of that with the third vector. But this, you see, this is a vector and this is another vector. When you dot product, you get a number. That number is volume of the parallelepiped determined by UVW. Well, if I leave it like that, there is something, a very small issue there, that this number can be a negative number. When you dot product two vectors, you can get negative number. So to kind of not to have that bad issue, we put absolute value of that number. It means that if it is negative, just drop the negative sign. If it is positive, you leave it like that. So that is the formula for that is the formula for this video, and we will do some examples for that. So let's just do example. Find the volume of the parallelepiped determined by these three vectors: 1, 0, -1, 2, 1, 3, and -1, 1, and 2. Well, doesn't matter which one you pick u, which one you pick v, which one you pick w. The important thing is that the formula, you have to find cross product of two of them. So I will first find u cross B. Any two of them, you choose any two of them, that will give you. So this is a vector in R3, which is, okay, 1 0 negative 1 2 1 3. Well, the first component, you ignore the first column, then determinant of 0 negative 1 1 3, then ignore the second column, and then the remaining 2 by 2 matrix, which is 1 negative 1 2 3, find the determinant of that and multiply it by negative sign. Then the third component, you ignore the third column and find the determinant of given matrix. Well, this is equal to determinant diagonal entries 0 times 3 0 minus of diagonal entries. Negative 1 times 1 is negative 1, so you get that. Minus diagonal things, 1 times 3 is 3, minus of diagonal is negative 1 times 2, it's negative 2. Diagonal is 1 minus 0. So this gives us 1. This is 3 plus 2, 5. And there is a negative sign. This is negative 5 and 1. So we found U cross V. Then the next step is multiply what you found before, or find the product, dot product of what we found, 1 negative 5 1, to the third vector that we haven't used yet, so negative 1 1 2. This gives us first component to first component plus a second component to the second component plus third component to the third component. This gives us negative 1 negative 5 plus 2, which is negative 4. Well, then the final step is the volume is equal, not the number. So what we found is 1 0 negative 1 cross 2 1 3. Then we found dot product of that with negative 1 1 2. Don't forget, there is an absolute value here. That is very important and very necessary to remember. So it will be absolute value of negative 4. Absolute value of a negative number, it means just drop the negative sign. That will be equal to 4. The volume of the parallelepiped determined by these three vectors is equal to 4. You have to remember that formula, and you have to be able to use that formula to find the volume of given parallelepiped.